All right. Well, let me see. I think you named it sticks with an S at the end instead of stick.
Oh,
Yeah.
it's always the little things.
It's the little things, yeah. So that's there, and I can execute it and I can grade it. Um, but going forward, right, I'm going to need the name to be exactly what the assignment says. Otherwise, it'll be a point deduction or a deduction of points, not just 1 point. Um, but I can work with what you got here. That's fine.
Thank you, sorry.
No problem. And the reason I'm being, you know, a stickler with details is because you're going to run into, you know, people the rest of your life who are sticklers for details. And you know, for me it may mean an email, it may mean you lose 5 points. For somebody, you know, that you're applying for a $500,000 loan for your business from, it may mean you don't get the loan, right? For a house that you're trying to buy, it may mean you don't get the house. So and certainly for assignments that you're turning in, it may mean a 0 on the assignment, right? Which could mean an F in the class. So I'm being really picky about this, you know, to help you know, build habits of worrying about that kind of stuff. Just because a lot of people in a lot of situations, the stakes will be a lot higher than CSE 224. So that's what's going on with that. All right, send me an attendance note, please. Let me know you are here. And other questions, other issues. All right, let me talk about subshells first. This is sort of a final topic in Bash for now. We'll come back to Bash later, but let me just kind of wrap this up because this ties into things like functions and passing information between one script and another and things like that. So what is a subshell? The idea is, you know, when we're in Bash, we can write scripts. So let me write a script called S1. And what my script S1 is going to do is set x equal to 12. Okay. Not a very exciting script, but you know, that's what it does. It sets x equal to 12. So if I say S1, right, what do I expect x to be equal to? I expect it to be equal to 12, but if I look at the value of x, it's not 12. It's nothing. It's unassigned, right? So I can go into S1 and I can say, you know, echo, hey, I just set x. The value is, and let's look at the value of x. So if I say S1, hey, I just set x, the value is 12, right? But if I echo $x, it's not 12. So here's what's happening, right, with Bash. So I'm sitting here in my Bash shell and I've got a prompt. And I say, let's go ahead and run S1. The first thing that happens is a new instance of Bash begins. And then inside this instance of Bash, it says, you know, x equals 12, echo all of this stuff. And then it hits the end of my script, so this shell basically exits, and I come back here, and there's my next prompt. And this x equals 12 happened inside this totally separate instance of Bash. right? So it's like this was a totally different life, right? And now I come back to my previous life, and this stuff that happened, that was in, in my dream or something. And so the change that I made to x here has no effect on the value of x here. So there's a different thing I can do. I can use a command called source. It's actually just a keyword in bash. And if I'm sitting at my prompt and I say source s1, I'm not going to create a new instance of bash. I'm going to read the contents of s1, and I'm going to basically pretend that they just got typed in here. So I'm basically going to execute the command x equals 12, echo all of this stuff, and then come back to a prompt. But since this command happened inside, my current bash shell, if I look at the value of x after s1, it should have a value of 12. So here's what I can do. I can say source s1, and now if I echo $x, it's equal to 12. So that's just a useful way sometimes that you can put things into a script and have the results of that script happen, or apply when you come out of the script. So for example, haha is not a built-in command, right? I could set up an alias inside here. And I could say haha means echo that is funny. And again, if I just execute s1, that description of what haha should mean, the fact that haha should cause an echo, that happened in this other instance of bash. But if I source s1, and now I say haha, it tells me this is funny. And if I look at haha, it's an alias to echo, that is funny. So source runs each command from the script in your current shell. Yep, you got it. Perfect. And so this is what happens when you log in. There's a file called .bashrc that does a bunch of stuff. And this is basically sourced, right? If I try to execute this file, all of these things happen, but they happen in a subshell, a different instance of bash, right? And so I set my history size to be 2000, and I set up some aliases and things like that. Well, one of the things I do is I set my prompt. And ps1 is a variable. Whatever I set it to, that's what my bash shell will prompt me with. So I could say, let's set ps1 equal hello Nick greater than space. Okay, well, if I just execute bashrc, it ran in a subshell, right? It doesn't actually change my prompt here. But if I source bashrc, it actually executes each line of that file from my current shell, including the one that set my prompt to be, this other thing, instead of the usual number sign inside brackets. So that's one place where we use this, is if you make changes to your bashrc, I could always log out and log back in, but I can also source that file to make these changes happen. And then if I want to get rid of that, right, I could just source it again, and I'm back to where I was. So sourcing basically lets us kind of like import stuff from a script. And there's an opposite direction, which is exporting. And if we want to set a variable in here, for example, maybe I want to say I want to make a command called fun, right? So anytime I type fun, it says this is fun. All right, if I go into bash and I say fun, right, that doesn't happen, right? This alias that I set up was in that version of bash, and when I said bash to start a new version of bash, that alias hasn't been executed. So if I wanted this to happen, any time that I go into bash, I would put it in my .bash rc. But there's one other thing I can do with variables, right? So I could have a variable like, name equals Nick. And I can echo $name, and it tells me my name is Nick. Now if I go into a subshell and I look at name, it's not assigned to anything because this assignment happened in a different shell. But there's a command I can use. I can say export name, and that means anytime that I start a new bash shell, I want you to inherit the value of this variable. So now if I say bash and I say echo $name, it's got the same value that I had in the previous shell. And so if I run a script, that's basically running in a new shell, and any variables that I set up outside aren't available in that shell. But if I export them, then they will be available. Oh, yeah. So you can use aliases to do all kinds of fun things. Like make, a typo to a command, do something nasty or something funny. rm-rf /* would remove like every file in your directory. And all the subdirectories underneath. And there's all kinds of interesting games you can play with that. So aliases can be useful. And for example, we do our attendance checks, and at the end of class, I just save the chat transcript into a file. Well, I have a script that will go through that file and pull out the pieces that I'm interested in. And it's called clean-attendance, and it's in this subdirectory under that subdirectory under that subdirectory, right? But I have an alias called clean, and I can just say clean space the name of the file that I saved the chat in, and it will do all of the pre-processing on it, pull out the names, switch the orders of them around, alphabetize them, and so on and so forth. And it's just a convenience for me instead of having to remember this and type this and so on and so forth. So you can put all kinds of things in your bash rc. I think you can add, you can definitely add arguments to aliases, right? So clean means this. If I say clean space file2, it means all of this space file2. So you get arguments kind of for free. I think you can put multiple things in an alias, yeah. So we can do, date, print working directory, say hello. How can I not have say on my own machine?
You said Causeway.
Thank you. So if I set up alias to be, haha to be an alias for that, haha should do all three of those things. All right, let's talk about Git. So homework 2, which was like the first week of class, was kind of a setup for all the other programming assignments in this course. And if you created a CSE224, put that under Git control, and then made a subdirectory homework 002 add commit push, right? And if all of that worked, then when you're working on PA1, make a subdirectory PA1, make your files add commit push, right? And everything should work great. But particularly with Git, it seems like often things don't work quite as great as they should. So here's the idea, right? You've got your local Git repository. That could be the Linux server, it could be your VirtualBox, whatever. And you've got GitLab off in the cloud. and you create your initial repository and you do the git remote add origin and it links it to some repository over in GitLab. Okay, from that point forward, your ideal is do a bunch of work and then git add, git commit, git push, and everything that you did gets cloned over at gitlab.com. Do some more work, git add, git commit, git push, everything gets cloned. Do some more work, git add, git commit, git push, everything gets cloned. It works great like that, right? But if something goes wrong, right? Let's say I make some changes over here. I get rid of some files and I move things from one directory to another. And I type some git inits just for the heck of it, right? And I do some things like that. And then I try to do my git add, git commit, git push. When I get to git push, Git's going to say, hey, you've got, A, B, C, and you've got these things over here, and this is missing, and this is what I had in my repository. I don't know how to reconcile those. I don't know how to take what your local repository looks like and update my repository to look like yours, right? It would require me to make some assumptions that I'm not going to make, right? And another thing that can happen is, if you have a local repo number 2, and let's say you haven't done funny things here, right? So you've got everything in sync, and now you do some, IJK, and you push this over here, so you got IJK, and now you come into your local repository, and you start doing, an MNO, and you try to push that over. Git's going to say, hey, your repository looks like this, and my repository looks like that. How do I turn this into that? I would have to get rid of all these files and add this new file, and I don't see anywhere where you deleted all of these files from your repository. I don't know what to do here. And so you start getting all kinds of messages about fast forwards and merges and using the -force option and all kinds of things like that. And the nice thing about Git is it's keeping track of everything you're doing. So even if you do something really, inappropriate that ends up, wiping out all the files in your repository, the history of all your stuff is still in GitLab, right? But sometimes it's a pain to get to. Let's see, is this explaining what could go wrong with accidentally pushing one repository to a different one? Pushing it to a different repository would mean changing the git remote add origin business, and that's usually not a problem, but yeah, that can get you into some issues. So let's look at how we can get out of some of these quagmires. And again, you can always come to office hours and say, hey, here's what's going on, can you help me? And we can figure it out. And we were remarkably successful in most cases in doing that this morning, which really surprised me. All right, so here's my sample repository. I've got PA1, I've got S1. I don't have a homework 2 in here, but let's go ahead and put one in there. Okay, so one thing you can do is an ls-a, and there is a .git in here, so I know this is under git control, right? So I'm going to say git add star, git commit, and git push origin master. All right, that worked fine. And if I come over to GitLab, and I look at my CSE224 directory, right, there's my homework 2, there's the README I just added in. All that's working great. All right, so what can go wrong? Here's one thing. Let me make a temporary directory. Alright, there's my stick program. Alright, I've got my new version of my stick program pushed over to Git. Let's say I did this from the Linux server, right? Now I come back to my virtual box and I go into PA1 and I go into my stick file and I'm going to, you know, write my new code. Git add star, git commit, git push origin master. Alright, Git is confused now. Right? It's confused because I made some changes to my stick program over here, and I made some changes to my stick program over there. And now I'm trying to make some copy of my changes in GitLab, but I didn't start with, you know, these changes that I made over here. So this can happen if you work on multiple machines. It can happen if you know, delete all your work and start over again, but you don't tell Git that that's what's happening. It can happen if you do git init inside a subdirectory, right? There's all kinds of cases where this can happen, and you usually see, you know, things about fast forward in here and stuff like that. Okay, so whatever the cause, if git push origin master is not working, what do? I'm sitting here. Okay, so let's go back into my top level directory, and I see a .git in here. Okay, let's go into PA1 and do an ls-a. Okay, if you accidentally did a git init from here and you do an ls-a, you're going to see a .git, right? And I don't want a .git file anywhere except in my main directory, CSE224. So don't do git init or git remote add origin more than once, right? When you created your CSE224 directory, you did your git init, you did your git remote add origin, right? When you make a subdirectory under there, don't do git init again. Don't do git remote add origin, right? Because if you do that, you're creating an entirely new repository, and you're making a repository inside another repository, and you're trying to push them both to the same place on GitLab, and it just gets really confused. Okay, yeah, that header just said don't do git init or git remote add origin more than once. So what do we do? ls-a. Okay, I've got a .git in here. Let's get rid of it. rm-rf.git. And you got to be careful when you say rm-rf. Okay. Because rm-rf says, let's remove everything. Let's not ask if we should do this or not, and let's do it recursively. So it's going to get rid of the directory. It's going to get rid of everything underneath it, right? But I double-checked. I'm in the PA1 directory. That's what I want to get rid of. Okay, I'm going to do that. If I do an ls-a, my .git is gone. All right. So what's the cleanest way to do this? Okay, there's ways we can patch this. Let me show you how to patch this up first. But it may not be the easiest way to do this. But no, I'm not going to do that. We're just going to do the surefire way. Otherwise, this will be a week-long Git lecture. All right, something is messed up. Okay, what do? First thing I'm going to do, I'm going to I got a few options. I'm going to move CSE224, CSE224 old. Okay, I'm making I'm moving my directory into something else. Okay, I don't want to just delete CSE224 because it's got all my work in it, and I don't want to do too much funny business inside CSE224. Because, you know, if I mess up, I might lose my files. So I'm just going to take this current directory that has all my hard work in it. I'm just going to name it something else. So it's completely out of the way. Okay? And now I'm going to make a new CSE224. I'm going to go in here, I'm going to do my git init, and I'm going to do my git remote add origin, git at gitlab.com, Nick Macias, CSE224.git. Alright, so those are my, one time for the entire course setups, git init and git remote add origin. Alright, so I've got nothing in here. I'm going to make my PA1 directory. I'm going to change directory into PA1, and I'm going to say copy from my save directory, CSE224 old /PA1/stick. Let's copy that into my current directory. Period means current directory. So now I've got my stick program. Alright, that's all good to go. So I'm going to say git add star and git commit, and it'll tell me I'm about to add this new file. Alright, now I can go ahead and I can try git push origin master. I already have a 224 repository. There's a good chance if I try to push this, it's going to complain. But I can try it anyway. Right? But it's unhappy because, I had all that other stuff in GitLab before. So here's the easiest way to deal with this. Just delete your repository on GitLab. Now make sure, you've got your code that you care about, your carefully written stick program is sitting in your local machine, right? And then just go ahead and delete this project. So go to settings, go to the end where it says advanced, go to the end of that where it says delete, type in the name of the project, and then say delete the project. Alright, and that gets rid of that. And then do your git push origin master. And now if you come back to your GitLab, there's my CSE224, and I've got a nice clean repository with a PA1, and there's my stick program. And now going forward, if I, write a bunch more lines of code, and maybe I make a README file, right? So I've got this stuff sitting in here. Git add star, git commit, git push origin master. Right, and come over here to my project. There's PA1, there's the stick program, and if I look at the stick program, there's my new stick program. Now we're ready to get going on PA2, so I'm going to come up here, I'm going to make a dir PA2. I did that wrong, so I'm going to change the name. I'm going to go into PA2, I'm going to make, another README in here. This is program 2, right? What do I do? Git add, git commit, git push origin master. Come back over here, look in your project. Now I've got a PA2. It's got my README. It's got my message in there, right? So if you keep it in sync, right, it works well. It doesn't really get in your way. It's just kind of there in the background. You can alias a command like go that means, git add star, git commit -m something, and git push origin master. And really, when you're working on something, if you hit a stopping point, if you're going to go off and get something to eat, push your stuff over to GitLab. If you just found a bug and fixed it that you've been working on for 2 hours, push your stuff over to GitLab, right? Certainly if you're done with your project, push it over to GitLab, but just keep pushing it to GitLab, right? And if something goes wrong, if something got out of sync somewhere or something like that, right? Sort of the sooner you catch it, the easier it's going to be to fix, right? And you really don't want this to happen, like 15 minutes before the deadline, because not only is it hard to get, these things fixed in that short time, but you're more likely to make a mistake and do something like accidentally delete your only copy of your program, and then, it's bad news. All right, so yeah, there is no recycle bin with RM. There's only dust. This is true. So first archive the repository, make a new folder, and copy the new files to the old. Yep. If it's not a local repository, could it be easier to reclone the repository, then move changed files? You can do that too. Yep. Top five-ish ways for a repository to get jumbled. Probably. So the main thing that was hitting people who came in this morning was going into a subdirectory and doing git init, and then doing all of this stuff. And you start getting weird things like that. So doing git init or git remote add origin, more than once, more than just from the CSE224 directory, that's one definite gotcha. Deleting files without telling git about it. And so if you want to remove a file, really what you should do is git rm. And if you want to move a file, you should do git move. But it'll usually figure those things out, but that can get you into trouble. Definitely if you're working from more than one machine and you push a bunch of stuff over here, and then you start working on your files here without first pulling them from GitLab to get the latest copy, that's guaranteed to get you in trouble. So that's a third one. And I think moving directories around in particular is harder for Git to reconcile than moving files. Those would probably be the main ones, but I don't want to say there's only 4 ways. But those are the main ones I've bumped into for myself and with students. So yeah, the downside to completely just starting from scratch is you lose your change history, which is why I say you want to make absolutely sure that you've got the good files of your copy on your local machine, that you don't have an improved version sitting on GitLab that you don't have in your directory. So when moving, renaming directories, I think you can do that with git move. Right, I think that works. Yeah. Right, so that's all hunky-dory. And now if I go back to 224, there's my programming assignment too. Yeah, Git has its own move, it has its own remove. It's weird that remove is derived from move. I would think it was the other way. All right, so that's some ideas, and I'll just mention, but this can get you into trouble, right? If you're working on 2 machines, right? The main thing to do is, you do some stuff over here, you push it. If I come to a new machine and I want to start working on my repository from here, first thing I want to do is a pull. In other words, before I make changes to this, I want to make sure it looks like what's on GitLab. And if I forget to do that pull, and then I just do my push, that's where GitLab will complain about, hey, it doesn't look like you started with the same thing I have. I don't know how to turn what I have into what you have. And that's where it yells at you about fast forwards and stuff. So if you're working from multiple machines, right, you need to pull before you push. That's not going to be an issue for what we're doing unless you're working on more than one Linux machine with your GitLab repo. But if you're doing that, or if you start working on group projects where you have multiple people on multiple machines working with the same GitLab repo, then you got to get into this pull before you push business. But that's a topic for later. All right. Any other questions? Is there an option to auto pull? Well, you could set something up. There's not an option to automatically pull because I don't know how you would trigger it. But I mean, you could make yourself a command that you type, or you could change the CD command to do an auto pull, but that would only work when you were going into a GitLab directory and so on. And it feels like that would be kind of dangerous because maybe something happened to your GitLab repo, and so you want to work with your only copy of it, and you go into that directory and it automatically pulls from the corrupt repo or something. So, but you could make yourself an alias for it. But it's really just a matter of getting in the habit, and it's a hard habit. I mean, I've been working more with using Git from multiple machines, and I still mess this up, right? It's something that's going to take a lot of practice, so that every time you start working, you pull down from the repo first. And I swear, once in a while, Git just wants to mess with me, and just says, "I'm going to pretend that you messed something up." So, so there's that. Say you do a bunch of work on a second machine but forget to pull. Does that mean when you pull, it will overwrite your existing work? So this is where Git is actually pretty good, right? Let's say I come over here, and I'm almost tempted to actually let's recreate this. All right, so because one thing I'm realizing is that I don't think there's anywhere in the CS curriculum where students are actually taught details of Git. And a lot of students get to, a university and they're expected to understand Git, and they kind of learn it like on the job. So let's play with this a little bit. So I'm in my copy of my repository. So let me do this. So let me clone my repo. Alright, so everything is all set right now. So I'm going to go into CSE224 on my second copy, and I'm going to go into PA1, and I've got a stick game here, and I've got a stick game here. Okay, so let me make this something that we can actually work with. Alright, there's my stick program. And you can say, git commit -m and just specify what you want the commit message to be. Okay, and then git push origin master. Alright, so that's all set. And so over here, my stick program is my old version, so let me say git pull origin master. And there's the new version of the stick game. Alright, so everything is in sync right now. Alright, so let's break this. So it has 5 lines. So this is a good day to Git. Alright, so I'm putting all 3 of these commands on one line so I can pull them back really easily. Alright, so that's the version that's on GitLab now, right? And if I go to GitLab and I look at CSE224 PA1 and I look at stick, it's got 5 lines to it. Alright, so here's where I get into trouble. I come into stick and I say it has, 6 lines. The new lines will go here, I mean. Alright, so that's my new version, and I try to push this over. Alright, so it's complaining to me. that it doesn't know how to do this, and it says do a git pull first. Well, maybe it does. Yeah, do a git pull. Okay, so what's our situation? So I started with version 1 of my code, and then I changed that to version 2. I started to version 1, I pushed that to GitLab, and then I pulled that to version 1 over here. And then I changed this to version 2, and I pushed that into GitLab. So now version 2 is the latest version. But then I changed my version 1 over here to version 3, and I'm trying to push that. And it can't understand how to update this because, you know, here version 1 got changed into something else. Here version 1 got changed into version 3. And my GitLab repo is looking at version 2. And it's got some extra stuff from here and some extra stuff from here and so on. So what I'm going to do is I'm going to pull version 2 into this repo. And that's going to do some interesting things. So git pull origin master. And it's going to tell me there's a conflict, right? So it tried to automatically merge these two versions and it wasn't able to. So fix conflicts and then commit the result. Because if it had simply pulled, you know, this version 2 into my repository, I would have lost my version 3 changes. So I can go into stick and I've got some extra stuff in here, right? So this was what I had in my code, and this is the part that GitLab has that it doesn't know, you know, what I want to do with that. So I can go through here and I can say, oh yeah, okay, so I wanted to keep those lines, and I wanted to keep those lines at the end there. Okay, so now I'm going to do git add, git commit, and then I'm going to do git push origin master. I think I'm still going to have to pull. Nope, there we go. And then over here, if I say git pull origin master, and then I look at stick, it's got all that extra stuff in there. So yeah, this is definitely going to come up when you have group projects. And if you're doing your SLP in a group, or when we get to the group assignment in this course, because we'll have one programming assignment that's a group project, it's a good chance to start playing with Git. And, you know, always make sure you have a pristine copy of your code somewhere, right? Even when you've gotten to where you're pretty comfortable with Git, right? You're still hopefully doing your own backups, you're saving your work somewhere and so on and so forth, just in case something gets weird, right? But theoretically, you know, if I go to Git, I can look at the history of this file, and I can see all these different versions, right? So I can look at the file that I had back there, or I can find the version that I had, you know, after that, and so on and so forth. And you can download these, right? Or it will tell you commands that you can use to pull them from Git and so on and so forth. Let's see, I'm falling behind on chat windows here. Is there a way I can get a reminder for pulling, like a script that checks? Yeah, you could add, you know, make your own version of the CD command, and every time you go into a directory, it could do something with Git and looking at the Git repository and, you know, decide whether or not to print a message just saying, you know, don't forget to pull, something like that. All right, confused on what this latest segment should be when pulling. I need to make sure I pull the version I'm working on and not the latest. So right now things are in sync, right? So there's my stick, which I think has 7 lines on it and so on and so forth. So let's say I do some more editing here. So I'm going to edit my stick program, and this is the real code. And I'm just going to go ahead and git add star, git commit, and git push. All right, if I want to avoid all of those oddities, what I'm going to do when I come here, first thing I'm going to do is git pull, right? This is my current program. if I know that I've just made, those changes on another machine, or a teammate made changes on another machine, first thing I'm going to do is git pull origin master. And now I have a version which is in sync with the Git repository, and any changes that I make here, even if I make major numbers of changes, those will go over just fine. And then when I come to the other machine, or if I'm the other person and I want to start doing some work, git pull origin master. And there's my synchronized version of stick. So yeah, too long didn't read. Pull before you push. Pull before you do any work would be best, yeah. And if you do some stuff in here, well, we're kind of out of time. But if you're getting that message about fast forwarding, you can try to do a pull, but if you're not sure, just make a copy of your file somewhere else first, right? If I don't know what's going to happen, I can just copy stick to tilde slash good stick keep, right? And now whatever I do, whatever goes wrong, whatever gets messed up, I have a copy of my good code right here. And I can always, go back to that. And then if I have to, I can always just blow away the whole repository and start from scratch. So most important thing, always make sure you have a copy of your code somewhere outside of Git if you're going to do any funny business. How do I find overwrites after doing a pull? If you edit the file that got updated, it will show you that greater than, less than, notification of things that came from the old file, things that came from the new. And the way to learn this is to play with it, right? Do what I'm doing here. Make a repository that's not your CSE224 repository, but start totally new repository. Call it junk or something, right? And just play around with that. And you can run from two machines, or in my case, I'm just working from two different directories. I've got my junk directory, and then I've got another version under /tmp, and mess around with it, make changes, do things deliberately wrong, see what kind of trouble you can get into, figure out how to clean it up, and so on. And someday we'll talk about branches, and branches are where things get really funky. But okay, go ahead and send me an attendance note at the end here, and I will say goodbye for now, and I will see you next time. All right, have a good one.